Greetings. In this one, let's talk about a linear map from V to W, and V is finitely generated, and we have this thing. That if this is an epimorphism, which means it's a surjective map, all right, map onto all the vectors in the codomain. And a short way to talk about surjectivity, all the codomains elements are mapped into. Well, or for every y there is an x from which under f of x is y. If this is an epimorphism, and by the way, V is a vector space finitely generated, well, then for any set of generators consisting of some v1 till vk, v1 until vk, so some k vectors that generate all of v, we have this set f of v1 until f of vk generates w. So it's a sufficient set that it generates all of w. In other words, a set of generators of w. Generating set of w. Well, the proof is quite straightforward. It uses linearity and such. So for any w inside the vector space w, so take any vector from the codomain vector space here, and by surjectivity there must exist some x in the initial vector space V such that under the map it gives the w. Alright, that's because of surjectivity, because it's an epimorphism. And because, or let's just write it as an implication for quick notation. So V1 till Vk generates V. That implies x can be expressed like a linear combination as a linear combination such that x will be equal to some c1 v1 c1 v1 plus 3 dots until ck vk, so some k constant scaling up the set of v1 till vk to be to make a linear combination out of it. And then because of the linearity of f, we also have the following. Obviously v is f of x as we wrote, and that is f of c1 v1. Now this is always long to write, but by linearity we can take out the constants and also split up like this. Alright, and thanks to this fact we easily found out that every vector w inside the codomain can be expressed as a linear combination of f of v1 until f of vk. And so basically, by these words that I said, that could be written down in a more formal proof, but all of that altogether implies that yes, f of v1 until f of vk indeed generates w right here.